Alright, so welcome to this video lesson, and today's video lesson we're going to be looking at work done in a force field. And in the force field we're actually talking about is the Earth's gravitational field. Alright, so remember that work done is actually equals to force multiplied by distance. Right? Good. And remember that force is mass times acceleration, right? Multiplied by d. Now because we're dealing with Earth's gravitational field, then we're going to change this acceleration to acceleration due to gravity. Then since acceleration due to gravity has to do with height, then that's the vertical distance, not horizontal distance. Since g, acceleration due to gravity, is acting downwards, right? And distance is actually in this same direction, then they are in both the same direction, d. So I'm going to call this h. So work done in that case is actually going to be mgh under Earth's gravitational field. All right, good. Where your m is your mass, your m is your mass, your g is acceleration due to gravity and is 10 meters per second, and it can be except otherwise stated. Then you have your h to be your height. So this is the parameters for that. So let's take a few examples on that. All right, so we have this example: a boy of 50 kg climbs up a ladder. So the ladder is what's the height of the ladder? 10 meters high. Okay, so that means the mass of the boy is actually 50 kg. The height of the ladder is actually 10 meters. And then g, acceleration due to gravity, as stated here, is 10 meters per second squared. And so what's the work done? So in this case, work done has to be mgh. And so work done has to be 50 multiplied by 10, then multiplied by 10. And that's 5,000 joules. And if I divide it by 1,000, I can write that in kilojoules. And that 5,000 divided by 1,000, I have 5 kilojoules. Okay, good. So that's that. Let's take another example. All right, so here we have this example: a stone of mass 20 grams, so 20 kilograms rather, 20 kilograms, falls from a height of 2 meters. Calculate the work done. Of course, you know that g should be 10 meters per second squared, acceleration due to gravity. So the work done in this case has to be mgh. All right, good. So work done has to be, what's the mass? 20. What's the acceleration due to gravity? 10. What is the height? 2. So work done has to be what? 2 times that. All of that has to be 400 joules. So that's how simple these kind of questions are. But if you don't know the formula, you don't know what to do. So let's take one more example before we call it a day. So now we have this example: a load of mass 3 grams slides down a smooth plane. Slides down, that means it must be something like this with an inclination of 30 degrees. Okay, good. I know that is something like this. Where's my not straight? Oh god. Okay, let me see. All right, okay, then it's sliding down. Be good. Inclination 30 degrees. Now I said the plane is actually how long? 10 meters long. So the plane is 10 meters long. Okay. Now that's the first point from A to B. This is A and this is B. Okay, good. The same mass is dropped. The same mass is dropped from point. Oops, sorry. If it's from A to C, that means this part has to be C. Then this is A. Pardon me. This is A. I better let me use red. So this is A. And this is B. Okay, good. Then this is C. Alright, so from A to C, first down vertical height then is what? 5 meters. Vertical height, 5 meters. Okay, so what should we do? And we're asked to calculate for what? In which of the two situations has more work done? So that was what we have to do for two cases. Let's start with case 1. Case 1. So for case 1, we're having it like this. 30. Then we have here to be 4 meters. Sorry, 10 meters rather. Alright, good. Then what's the mass? The mass is actually 3 kg. Okay, good. Then this forms something like a triangle, if I'm not mistaken. Yep, like a triangle, and this is B, this is A, right? And this is C. Good. So that means this has to be my opposite, and this has to be my adjacent, and this has to be my hypotenuse. Then from the knowledge of SOHCAHTOA that we have, all right, good. So we know that work done, first recall that work done is actually what? MGH, right? Because it's also falling from a height, MGH. But we don't know our height. We don't know our height. We don't. Okay, but we know that sine, in this case, we don't know our height. But we know that we need opposite height and we have hypotenuse. So what am I going to do? I'm going to use sine. So that sine theta equals, what's my opposite? AC divided by hypotenuse 10. So cross multiply AC, which is our height, now becomes 10 times, well, theta is 30, sine 30 degrees. And so what's our sine 30? Sine 30 is half, and that's 5. Okay, so in this case our height is 5. Okay, so work done becomes mass. What's the mass? 3 kg. 3 multiplied by acceleration to gravity is 10, and we've calculated for our height, that's 5. And that gives us what? 3 times 10, 30. 30 times, it's supposed to be times here, 30 times 5. What we get is 150. So that's 150 joules in case 1. Then in case 2, in the second case, it is falling 3 kg, height of 5 meters. So what do you see? Say that work done equals to mgh, and that gives us mass times, sorry, what's the mass? 3 kg multiplied by acceleration to gravity 10 multiplied by 5, and that still gives us 150 joules. So what is the difference between this and case 1 and case 2? there is practically no difference in their work done. The work done is the same. So that means in case 1, if you are given something that has to do with inclined plane at an angle, then just look for the height here and multiply by mg, by the mass. This is mass m. Multiply by mg and you're done. So that means a mass sliding and a mass falling from the same height basically have the same work done. So far the height is the same, just like in the example we did, the height are the same, the vertical height is the same, so the work done is just basically the same. So let's see, what about this? Can you quickly just calculate the work done for this? This is right angled, so this is let's say the mass of this is actually 2 kg and the length here is 4 meters and the angle here is 30 degrees. Can you quickly do the rough sketch, pause the video and actually solve this? All right, assuming you have done that, so I'm going to have mgh, but I don't know my h here, so I can basically just replace that with mg sine theta multiplied by the hypotenuse L. That's the length of the plane. You can do the math yourself. So you have mass, that's 2 multiplied by 10 multiplied by sine 30 multiplied by 4. Then I have 2 multiplied by 10 multiplied by 1 over 2, 10 multiplied by 4. 2 here, 1, 2 here, 2, and 2 times 2 is 4, 4 times 10 is 40 joules. So the work done here is 40 joules.